So, time is a strange thing to think about, but it gets even stranger in a black hole. In simple terms, a black hole is just a distortion of space and time due to a mass squashed into an infinitely small point called a singularity. Einstein theorized that space and time swap places inside a black hole. To understand this, let's talk a little about space-time, a fourth-dimensional concept that considers both an object's position in three-dimensional space with respect to time. We can simplify this to one-dimensional motion with respect to time so that both can be graphed in a 2D plane. Vectors will represent the time and position properties. The traditional spacetime model is a 2D grid like this. But recall that a black hole is a distortion of spacetime, and that looks something like this. In our 2D graph analogy, when considering time, our particle can only move to the right, just as time only flows in one direction forward. However, when it nears the spacetime distortion, the time vector starts to turn downward. The vector that represents position subsequently becomes the horizontal vector. This explains why it would appear to an outside observer that space and time swap places. Because the time vector is oriented downwards, the particle's journey toward the singularity is now inevitable, just like how the passing of time is. It is also easy to visualize now how the event horizon is behind the direction of time, indicating that it is as impossible to escape as it is impossible to travel backwards in time. Note how the curvature of the space-time distortion resembles a graph nearing a vertical asymptote, which to our outside viewer is a single instant in time. Thus, as the particle nears this figurative asymptote, it would appear to the observer that the particle never reaches the instant of time where the singularity lies, only forever gets closer until it appears to freeze in time. Ultimately, the real mystery is the fate of objects that cross the event horizon. Maybe only time will tell. Thanks for watching.